A data flow diagram is a graphical representation of the flow of data through an information system, modeling its process aspects. Often they are a preliminary step used to create an overview of the system which can later be elaborated. DFDs can also be used for the visualization of data processing. A DFD shows what kind of information will be input to and output from the system, where the data will come from and go to, and where the data will be stored. It does not show information about the timing of processes, or information about whether processes will operate in sequence or in parallel. Theory. It is common practice to draw the context-level data flow diagram first, which shows the interaction between the system and external agents which act as data sources and data sinks. This helps to create an accurate drawing in the context diagram. The system's interactions with the outside world are modeled purely in terms of data flows across the system boundary. The context diagram shows the entire system as a single process, and gives no clues as to its internal organization. This context-level DFD is next exploded, to produce a Level 1 DFD that shows some of the detail of the system being modeled. The Level 1 DFD shows how the system is divided into subsystems, each of which deals with one or more of the data flows to or from an external agent, and which together provide all of the functionality of the system as a whole. It also identifies internal data stores that must be present in order for the system to do its job, and showed the flow of data between the various parts of the system. Data flow diagrams were proposed by Larry Constantine, the original developer of structured design, based on Martin and Ostrin's data flow graph model of computation. Data flow diagrams are one of the three essential perspectives of the structured systems analysis and design method SSADM. The sponsor of a project and the end users will need to be briefed and consulted throughout all stages of a system's evolution. With a data flow diagram, users are able to visualize how the system will operate, what the system will accomplish, and how the system will be implemented. The old system's data flow diagrams can be drawn up and compared with the new system's data flow diagrams to draw comparisons to implement a more efficient system. Data flow diagrams can be used to provide the end user with a physical idea of where the data they input ultimately has an effect upon the structure of the whole system from order to dispatch to report. How any system is developed can be determined through a data flow diagram model. In the course of developing a set of leveled data flow diagrams, the analyst designers is forced to address how the system may be decomposed into component subsystems, and to identify the transaction data in the data model. Data flow diagrams can be used in both analysis and design phase of the SDLC. There are different notations to draw data flow diagrams, defining different visual representations for processes, data stores, data flow, and external entities. See also, business process model and notation, control flow diagram, data island, data flow, directed acyclic graph, physical data flow, logical data flow, functional flow block diagram, function model, IDEFO, pipeline, system context diagram, structured analysis and design technique, structure chart, activity diagram, topics. Further reading, Scott W. Ambler. The Object Primer 3rd edition Agile Model-Driven Development with UML2, External Links, DFD Template in Visio, Case Study Current Physical Data Flow Diagram for Acme Fashion Supplies and Accompanying Elementary Process Descriptions, Jordan's Chapter on DFDs, Example of Using Presentation Data Flow PowerPoint Diagram.